In this video, we're gonna talk about the extrema subject to constraint. The idea for this one will be you like to find the relative extrema of the function. So it's gonna be relative maxima or relative minima of the function. However, it's not gonna be any xy in the domain. It's gonna be the xy that you like to specify. So it's gonna be the constraint. The constraint that gonna be in the form of gxy equal to 0. So it's gonna be like you're gonna know the relationship between variable x and y, and sometimes you may be able to convert the problem into the single variable calculus. For example, the first example asks you to minimize the function fxy equal to x squared plus 3y squared plus 10 subject to the constraint 8 minus x minus y equal to 0. So for this one, you see that you allow to solve for y. So you have y equal to 8 minus x like this. And you're gonna just plug y equal to 8 minus x that you have here into the function fxy. So you'll be able to get rid of y. So in this case, you would have fxy given by x squared plus 3, 8 minus x squared plus 10. Okay, and you see that you have no y anymore, so you're not gonna have fxy, so you're gonna have the function in x only. So for this one, you simplify, or you're gonna find the critical point like you have in Cat 1. So you're gonna differentiate this guy one time. So you have f prime x equal to 2x plus 6, 8 minus x times negative 1. Okay, so for this one, you're gonna use the technique in calculus 1. So you find the critical number by letting the derivative equal to 0. So you have 2x plus 48 minus 6x. Okay, so it's gonna be, I have the mistake. So in this case, it's gonna be negative 48 plus 6x. Okay, so you see that you multiply these three numbers together. So in this case, you would have 8x equal to 48, and you have x equal to 6. Okay, so this one. And you see that if you graph f, this guy is going to be parabola open up. When you have parabola open up, you're going to have the minimum. Okay, so you have the minimum, and the question already tell you that it's going to be minimum. So this one is going to be, you don't need to test anything. The question turned out to give you the minimum or maximum already. So it's going to tell you that it's going to be minimum. And this one is because of the shape of the graph turned out to be the parabola open up. Okay, so this one will be fx equal to this one. So this one gives you the parabola. Don't forget that this guy is y equal to something. I cannot say y. I have to say z. So it's going to be the parabola open up. Okay, so you have x equal to 6. Okay, and you're gonna have to what? You're gonna have the y, okay, minimize the function. So you're gonna solve for y. In order to solve for y, you're gonna put this number into this constraint. Okay, so you're gonna have y equal to 8 minus 6 equal to 2. So we have relative minimum at 6, 2 with the value okay, equal to f62. So f62 equal to what? So it's going to be 6 squared plus 3 times 2 squared plus 10. Okay, and that will be the number that you have. So it's going to be, so it's 36 plus 12 plus 10. So it would give you 58. Okay, so this one will be the way that you're going to get relative minimum for this function. Okay, so it's going to be relative minimum subject to the constraint 8 minus xy. So you see in this situation that it's turned out to be calculus 1. Okay, however, we're gonna use other method. The method that we're gonna use is called the Lagrange multiplier. Okay, so this one is Lagrange multiplier in order to find the relative extrema of the function fxy subject to the constraint gxy equal to 0. So let me explain this one. So you have the constraint gxy equal to 0. Okay, so you have the constraint gxy equal to 0. You're gonna form an auxiliary function. The auxiliary function that you're going to form is going to consist of two parts. The first part will be the part of fxy. Okay, so the first part will be the part of fxy. The second part will be the part for gxy. Okay, and it's going to be, you're going to see that you're going to have lambda multiplied to this one. So this symbol is called lambda. Lambda. Okay, so this lambda will be called the Lagrange multiplier. Okay, so this one will have a name called the Lagrange multiplier. And you have fxy lambda. This one will be the new function, which is the capital F. Okay, and it's turned out to be this one. And you're gonna find derivative with respect to lambda, derivative with respect to x, and derivative with respect to y. Okay, so you have the partial with respect to lambda, with respect to x, and with respect to y for the capital F. Okay, so let me emphasize on this one a little bit. So you have the new function, which is capital F, and you're gonna dip this guy with respect to lambda. When you dip this guy with respect to lambda, you're gonna get g, and you're gonna solve for the system f lambda equal to 0, fx equal to 0, and fy equal to 0 for x, y, and lambda. Normally, we're gonna solve for xy. Okay, so normally we're gonna solve for xy. However, lambda will be the thing that we gonna have to use also. And the last step will be we're gonna evaluate if at each point xy obtained in the second step, the largest one will be the maximum and the smallest one will be the minimum. So basically in this one, it's gonna consist of 3 steps. So you're gonna form an auxiliary function and you're gonna kind of find the critical number. So however, in this case, you're gonna have to use also the constraint. Okay, and then you're gonna plug in. So it's not going to be like a second derivative test or anything. So it's going to be just plug in order to find the maxima or minima of the given function. Okay, let's go back to our original example. You have fxy equal to x squared plus 3y squared plus 10. So this one will be the function that I highlighted pink before. And the constraint is gxy equal to 8 minus x minus y equal to 0. So this will play the role of gxy. So in this case, gxy will be 8 minus x minus y. Okay, and you will have to form an auxiliary function. So it's going to be the capital F x y lambda equal to x squared plus 3y squared plus 10. And you're gonna plus lambda, and you have 8 minus x minus y. So in this case, you have the yellow guy and you have the pink guy. Okay, so you have something like this. And then the second step, you're gonna compute f lambda. F lambda is gonna be just the yellow guy, just copy. No need to differentiate. Okay, so f lambda will be just the constraint. And you have fx, now you need to differentiate. So it's gonna be 2x, okay? And you differentiate with respect to x, so it's going to be minus lambda. And you have fy is going to be 6y minus lambda, and you're going to let them equal to 0. The trick for here is going to be, you're going to solve for lambda, so it's going to be lambda equal to 2x, lambda equal to 6y, okay? So with the way to solve this one, normally I'm going to tell my student that you just solve for lambda. So you're going to have lambda equal to 2x and lambda equal to 6y, and you may let them equal. So from here, this will allow you to obtain 2x equal to 6y, and you would have x equal to 3y. Okay, so you have x equal to 3y, and you would plug this guy into the constraint. So you have 8 minus, and you have x equal to 3y. So you're gonna plug in 3y minus y equal to 0. Okay, so you have 3y like this, and you're gonna solve for y. So you have 8 equal to 4y. So you get y equal to 2 as before. After you have y equal to 2, you're gonna plug in to x. So you get x equal to what? X equal to 3 times 2 equal to 6. Okay, so this one you get x equal to 6. You see, it is the same solution. So you have f has a relative minimum at 6, 2. How would we know it's going to be relative minimum? It's already tell you in the question. Okay, so it's question going to be the minimum. Okay, you don't need to test anything. So this one, you have only one point. You cannot compare anything, right? So you're gonna have to just read the question. The question will tell you that it's gonna be minimum or maximum. Okay, and this one with the value f 62 equal to 58 that we computed earlier. Okay, so for this one, you have only one point that satisfies the equation f lambda equal to 0, fx equal to 0, and fy equal to 0. So you not be able to compare with any other point in order to get the largest, the smallest. So the way to know whether you're gonna get maximum or minimum turn out to be, you just read the equation, okay? The second one, okay, you like to find the minimum and maximum value of the function fxy equal to x times y subject to the constraint x squared plus 4y squared equal to 4. So for this one, the function is x times y, okay? And the constraint is the yellow guy, x squared plus 4y squared equal to 4. So you're gonna let one side equal to 0. So you get x squared plus 4y squared minus 4 equal to 0. And this will play the role of gxy, okay? So you form the auxiliary equation. So you have f x y lambda. Okay, so you're gonna have x y, which is the pink guy, and you have the yellow guy, which is x squared plus 4y squared minus 4, and you're gonna multiply with lambda. Okay, so this one will be the yellow function gxy. Okay, so this one is the lambda, not the lambda, the auxiliary function. The second step, you're gonna compute f lambda. F lambda gonna be just copy the yellow guy, and you have fx. You differentiate, so you get y. You get to lambda x fy, so it's gonna be x. You get what is called, it's gonna be 8 lambda y, and you're gonna let them equal to 0. So this one will be the equation that will solve for lambda. So you would get lambda equal to negative y over 2x, and you get lambda equal to negative x over 2y. Okay, so for this one, you will get x and y will have to satisfy this equation simultaneously. Okay, so this one is going to be x and y, and you're gonna solve for the lambda, so you have this guy are the same, so you get negative y over 2x equal to negative x over 2y. So you would get, I have 8 here, sorry. Gonna be 8, it's gonna be 8, okay? And you see that you can get rid of, so it's gonna give you 4. So you would have 4y squared equal to x squared. Okay, so you have 4y squared equal to x squared, and this one you get x squared equal to 4y squared. So this guy is the blue guy. So you see that you plug this term into the original function. Okay, so you would have 4y squared plus 4y squared equal to 4. So you gonna just have y squared equal to 1/2, and this will allow you to get y equal to plus or minus 1 over root 2. Okay, so it's gonna be for y. And after you have y, you just plug this guy into this guy, and you gonna solve for x. So this would lead you to x squared equal to 4 and y squared equal to 1 over root 2 plus minus square. So it's gonna be 2. So you get x equal to plus minus square root 2. Okay, so this one will be for your x. Okay, so you gonna, actually I shouldn't do this one, sorry. I should separate two cases. So you have y equal to 1 over root 2. So you get x squared equal to 2. So you get x equal to plus minus root 2, and y equal to negative 1 over root 2. So you get x squared equal to 2. So you get x equal to plus minus root 2. Okay, so you get the point root 2, negative 1 over root 2, positive, sorry. So you get the point root 2, 1 over root 2, and negative root 2, 1 over root 2 in the first case. And in the second case, you would get negative root 2, 1 over root 2, and negative 1 over root 2, sorry. So in the second case, you get root 2 negative 1 over root 2 and negative root 2 negative 1 over root 2. Okay, so you would have 4 points, and you're gonna compute, okay, in the third step, you're gonna compute f at each point. So it's gonna be root 2 1 over root 2 f at negative root 2 1 over root 2, and this guy will be just 1 negative 1, and f at root 2 negative 1 over root 2, so you get negative 1, and you have f at negative root 2 negative 1 over root 2, so it would give you what is gonna be? It's gonna be 1. Okay. So in this case, you would have 1 negative 1 or something. So you see that this guy will be max, this guy will be max, this guy will be min, and this guy will be min. Okay, so you have two maximum and two minimum in this case. Okay, and this one will be the final answer, that you're gonna have maximum at 1 over root 2, and you're gonna have maximum at negative 2 negative 1 over root 2, and you're gonna have minimum at this point and this point respectively. Okay, so that will be the final answer. One thing that you may ask me, okay, normally the student, when I did this kind of solving equation, you're gonna ask me, hey, can you divide by x and divide by y like this one? Don't you afraid that this guy turned out to be 0? Yeah, I am actually. However, if x equal to 0 or y equal to 0, you see that if x equal to 0, you're gonna get y equal to plus minus 1. And if you have y equal to 0, you're gonna get x equal to plus minus 2. That can happen, right? So that can satisfy. However, you see that if you have x equal to 0, you must have y equal to 0. Okay, so you see from here that if you have x equal to 0, y will be 0. If you have y equal to 0, x will be 0. So you get x equal to 0, y equal to 0 instead. Okay, so it's not going to be solving for x and y in that way. So you have to see first that if you have x equal to 0, y must be 0. And if you have y equal to 0, x must be 0. So it's not going to satisfy our constraint. So we can just divide by x and divide by y. The algebra here is correct. Okay, so don't worry about that. Okay. So the next one, okay, the next one, you like to find the maximum and the minimum value for fxy equal to 3x minus y plus 5 subject to the constraint x squared plus y squared equal to 40. Okay, so for this one, you see that you have the pink function, which is fxy equal to 3x minus y plus 5, and you have the constraint x squared plus y squared equal to 40. That will be solved to x squared plus y squared minus 40 equal to 0. So this one will be the constraint for gxy. Okay, so this one will be gxy. Okay, so that will be it. And you're gonna have to form the function fxy lambda. So it's gonna be 3x minus y plus 5. Okay, and you're gonna add by lambda x squared plus y squared minus 40. So this one will be the yellow guy and the pink guy respectively. And then you're gonna differentiate with respect to lambda, which is the constraint. Okay, and you have fx. So for fx, it's gonna be 3 plus 2 lambda x, and fy equal to -1 plus 2 lambda y equal to 0. And this would give you x equal, sorry, I solved for lambda. Lambda will be just -3 over 2x, okay? And you have lambda equal to 1 over 2y, okay? So for this one, you get -3 over 2x equal to 1 over 2y. So you would get x equal to -3y. Okay, so when you have x equal to -3y, you're gonna put into the constraint. So you see that you have x equal to -3y, and you're gonna have -3y squared plus y squared equal to 40. This would allow you to get 10y squared equal to 40, and you have y squared equal to 4, okay? And after you have y squared equal to 4, you get y equal to plus or minus 2, okay? So you put into this equation, okay? And you have y equal to 2, and you have x equal to -6, y equal to -2, so you have x equal to 6, okay? So this would give you 2 points, so you get -6, 2, and 6, -2, okay? And the third step will be you compute -6, 2 and f6 -2, okay? For f -6, 2 is gonna be 3 times -6 minus 2 plus 5, okay? So this one will give you -15. Okay, and for the second one, you have 3 times 6 plus 2 plus 5, so you would get 25, okay? So you see that this one will be minimum, this one will be maximum, that allow you to compare them. So you get f is gonna be minimum at, okay, so let me conclude this one. F has a constraint maximum at 6, -2 with the value 25, and F has a constraint minimum, okay, at -6, 2 with the value -15. Okay, so this one will be our final conclusion after the third step. So you see that like in this one, okay, so the question and the number kind of nice to compute, and you have to be able to solve something like this during the assignment and during the exam, okay? So the algebra that we are performing here is not that difficult, okay? Okay, so the next one, will be you like to use the method of Lagrange multiplier to optimize. Okay, optimize is mean it's going to be maximum or minimum depending on the situation. And you like this guy subject to the constraint x plus y equal to 2. Okay, so this one again form an auxiliary equation. So you have the yellow guy and you have the green one. So you form f x y lambda equal to 2/3 x cubed plus y squared minus 2/3 plus you have lambda times x plus y minus 2. Okay. So this one will be the yellow guy. This one will be the pink guy. Okay. So you're gonna differentiate with respect to lambda, which will be x plus y minus 2 equal to 0. And you have fx, okay, differentiate with respect to x. So you get 2x squared plus lambda, okay? And you have fy equal to 2y plus lambda equal to 0 in this case. And then what? And then you see that this one will be, so you solve for lambda. So you have lambda equal to 2x squared, lambda equal to 2y, and they are the same. So you get y equal to x squared in this case. I forgot the minus sign. And you're gonna put y equal to x squared into the constraint. Okay, so you get x plus x squared minus 2 equal to 0. Okay, so this one, and you allow to factor into two parentheses. So you have x and x, 2 and 1, and you're gonna have plus and minus. So you would get x equal to 1 and negative 2. Okay, so you have x equal to minus 2, x equal to 1. So you solve for y. So you get x equal to minus 2. So you get y equal to 4. Okay, so you plug this guy into this equation. Okay, and you have y equal to 1. So you get 2 points. They are negative 2, 4 and 1, 1. And the third step will be you compute f at negative 2, 4 and f at 1, 1. Okay, so this guy, when you plug in x equal to negative 2, 4, you would get 10. Okay, f at 1, 1, you would get 1. Okay, so this one become maximum and minimum respectively. Okay, so you're gonna answer f has a constraint maximum at negative 2, 4 with the value 10, and f has a constraint minimum value at 1, 1 with the value 1. Okay, so this is how we conclude for this problem. Okay, so this one. So I would say that I did about 4 examples already, and you see that it's not gonna take long time to do. Okay, the idea is going to be just consist of 3 steps. okay, no second derivative, okay, and this one will be, sometimes you have to read the question in order to know maximum or minimum. Sometimes you have more than one point that satisfy this equation, and you're gonna have to compare them. So the highest one turn out to be the maximum and the lowest one turn out to be the minimum respectively. Okay, so next time we're gonna do the word problem and you're gonna see the application of this technique, and this technique is called the Lagrange multiplier. Okay, so that's all.